Window, Hangout. Ah! The other David W. codes much faster than I do. Come on down. I think yours is like all in 3D or something by now. Oh. We're plugging over there? Absolutely.
Didn't really change anything except.
How can you mute your mic?
It's not muted. Yeah, I was going to do that. Was muted.
Okay. If it's better now to hear the echo. Yeah, that's weird. Yeah, it wasn't you then. Wait.
The only thing I did really that I've changed is where I added a while loop for the simulation, so that way it keeps running indefinitely until I tell it to stop. And so I ended up finding a set. I did. Oh, I forgot to edit a breakpoint there. Got an animated set.
Nice.
It's really working. Look at that.
Oh, that's pretty cool. Wow.
So what was the seed that you used?
It's one on. It's one on that was on Wikipedia.
The wiki page.
Yeah.
That's a Gasper's gliding gun.
Yep. It constantly generates little gliders that go to the bottom right.
And also will continue going in the exact same pattern, generating the exact
It's like
same.
eyes, like spinning or something.
But yeah, this will run indefinitely.
Awesome. Okay. Well, this deserves, I think, a round of applause. As always, very cool. Okay. So, what did you learn tonight about this? What are some things that you're going to take away? What are some things that maybe you went back and redid? What was sort of your takeaway from this?
Hard to say. I mean, I haven't coded Game of Life before, but I'd heard of it before.
So you're familiar with it, sort of
Yeah.
coming in, understood what you need to do. Okay. Let's see. I see you've got a couple. Is that unit tests there, or I see the green bar?
Yeah, I do
Those
have
unit tests, okay.
did do a couple unit tests. Kill this.
I'm curious, which unit test did you choose to write? So what unit test did you find valuable in this?
Testing. I created unit tests for the isAlive function. I just created a simple 3x3 grid, and I checked every part of the grid plus a few that would be outside of it to make sure that those would all return what they should be. Also did testing the number of alive neighbors. Checked just a few of them plus a few that would be outside the grid. The ones way outside will have 0 alive neighbors.
And did you use test run development, or did you write the unit tests after you had all the stuff working?
I wrote them after.
Clear. Good to know. After you wrote the unit test, did you go back and make any changes to your code, or
Nope, it was all still the same.
okay. Are there changes that you'd like to make to your code? Either refactoring, cleanup, or
Clean up the code for reading a file. It's kind of ugly.
right on? Okay. Any questions for these guys?
Can we, I mean, if you have time, can we go through the complete code once again? Like, just on a higher level, this function is doing that.
Yeah. I can also copy and paste it to like Pastebin and put that on the page.
Yeah, if that's.
Should I put up to? Are you using GitHub for anything?
No.
Okay, no, GitHub would be another place, but yeah. I think next time I do this, I'm going to make GitHub a requirement for everybody.
So how would you do that in that Google Plus?
So what I was going to do is I copy and paste it to Pastebin and give a link to it to the on the Google Plus group.
Oh, that's right. Yours is all one file, isn't it?
Yeah, it's all one file.
Well, 2 including the unit tests.
Yeah.
Very good. What's good? That's it.
Okay.
Try to replace all the Zoom business space.
Right on. Okay. Any questions for him now, or? Okay, play the get off the stage music. Yeah, right on. Good deal. Yeah, another round of applause. Very nice. Okay. Where are other people at? You guys?
We did some cool stuff.
Scott?
We did kind of similar things with expanding the functionality beyond the scope of
Oh, yeah?
the project just for fun. So pretty much the first thing we did was, let me make it bigger again, was kind of get rid of the file in and just randomize the start. So here we
I
can set
understand.
how big we want it to be,
Yeah.
and then it'll just create a random thing. The other thing we did was make it do multiple runs through, so we could kind of find out like what's the average number of iterations it takes before the population will stabilize,
Oh, cool. Okay.
and then like what's the average and the maximum and minimum. But we also found out pretty quickly that sometimes it doesn't, or it seems like it should always stabilize. At least we kind of like think it probably will, but it can take, the loops can be huge. It can be like 10 loops. Or maybe 20. There's probably no upper bound to like how many iterations it takes before it actually loops. So there could be like a massive loop. We ended up testing for only 6 generations, so we don't test that many.
So
But we have,
So how do you like maintain each generation back? Okay.
and they're kind of like silly names, but just like old.
Oh, okay, right. Yeah. And
At
it's hard
first,
going to
at
6.
first, at first it wasn't going to be that big, yeah. But then we're just doing this populations to stabilize, where it does some comparisons of the different generations.
We also thought, though, that there could be patterns within that would repeat on different generations.
Yeah, so it's possible
So
like
kind of hard to
maybe like one
find.
pattern here could repeat like every 3 generations, but one pattern here might repeat every 5. And so then like only every 15 generations would, you have to
The
check.
whole thing repeats.
Yeah, you have to check
yeah.
15 to actually see. That's why the loops we think can get really big.
Right.
Because say there's like 3 of those and they're all like primes or something, it'll actually be a high number when you multiply them all together. But then if we run it real quick, it's kind of like theirs. You can see like the patterns kind of develop. We'll see. Sometimes the infinite loop, sometimes it gives the stats at the end if it actually, like here we get the end. So like 1624 is the max generations before this one stabilized. The
Wait,
minimum
did the
was,
1600 generations really go by?
yeah,
You display each
for one of
generation?
them. Yeah.
Oh, wow, okay.
And then one was 136. That was the least amount of generations it took. And so the average was 554. And try to get one here. If maybe we can get one that infinite loop like theirs. This one looks like a good candidate because it's at 10,000
Yeah,
right now. So yeah, this
Only
looks like
macro.
one that's just going to run forever, kind of like theirs. Although it's not nearly as cool looking.
What do you mean by stabilizing?
Where just some kind of pattern repeats, but we only check 6 generations back. So like in those 6 generations, there's a loop. And I guess our loops, because we're checking 6 generations, the maximum loop length can really only be 3. Because we want to make sure that it repeats twice so that we know it's
I
actually
mean,
looping.
the population is stable right
Yeah,
here.
it's-
you know,
yeah, it's
but,
stable
I mean,
here,
Just
but-
repeating the exact.
I see.
Yeah.
I see.
We just don't know when we can't tell here, like when did it actually stabilize.
I see.
Because we'd have to extend our loop detection function, probably generalize it so that it can check potentially a ton of generations back. So that's kind of what we ended up doing.
Nice. Okay. Good deal. Another round of applause. Okay. Anybody else want to share where they're at? Trying to think. I'll talk about where we're at. No, if we're once again, test-driven development is is finding that I'm not a terribly careful coder when it comes to math things. It was pretty funny, like the logic for what was it? It was like determining the bounds. It was like I found, I think, one of the reasons that test-driven development works well for me is that like when I'm sort of in there in the details of the code, I keep missing things like greater than or equal to. I just kept having greater than, and if it wasn't for the fact that I had a test that would like tell me right away, it's like, hey, something's wrong here, I would have completely missed it. And then trying to debug it would just be, be a real pain. So like, what was it? It was, Oh, it was just things like if the spec was. Let me go back to the test here. It was like or someone with 3. It was like any live cell with more than 3 live neighbors dies, and more than 3 live neighbors. I had initially implemented it as number of live neighbors greater than or equal to 3, which was fine because I had an example that was 3 because I totally misunderstood the spec, and then luckily I caught it because a later test implemented the one where its number of live neighbors equals 3. That means it should live on. But anyway, so I think test-driven development helped me there, but I think compared to some of the other guys, it's still going much slower. Where we're at right now is what? I think we've got all of the logic for moving a cell to the next generation working. So actually not all of it. Because I think we've got all the rules implemented, but I'm not sure what to do in the default case. So like if it doesn't meet any of those conditions, does it stay in the same state or does it
Yes.
die?
If there's no set condition or no set state, it stays in whatever state it's in.
Okay.
If it doesn't mean anything, it just stays the same because there's no input to be taken.
Is that what you guys, is that right? Is that what it is? So if it doesn't meet any of the rules, so that those 4 rules, if none of
By
those
default,
apply,
it's got to meet one of the 4 rules to begin with.
does it?
Either less than 2, greater than.
So I should never hit this unsupported operation exception because I've.
Correct.
Okay, then I should leave it here.
As
Yeah, right. Should not reach here. Ooh. Now I'm really interested. Okay. Anyway.
There's only 4 possibilities. Either you have enough to die, enough to generate, or enough to stay the same. Those are your 3 outputs, and your 4 rules happen to fit all 3 of those.
But it's like you've got the alive or dead.
You have
So like if I'm dead,
you're either going to stay dead or you're going to come to life.
am I?
Yep. There's only 2 possibilities: remain or switch.
Okay, so let's. Okay, well, I need to see some examples. I don't have all the logic in my head, obviously. So how about? Well, I'll keep working on this. Hey, it's 8:30, so feel free to continue to keep working. But that's all I think I've got for tonight. So I want to finish. If you mind staying around for a little while? Okay, let's. Yeah, I want to make a little bit more progress on this, and I'll put the videos up. So if you are so inclined to watch me code slowly and make mistakes and stuff like that, you can.
About like test-driven development.
Yeah.
And, do you find it's easier to find ambiguities in specifications or find your misunderstanding of specifications when you do a test?
Absolutely, that's what we're finding here. It's like I don't. He's awesome because he's got the game of life. He's worked with it a lot. He's got it internalized, and so he can just like look at the test case and say, "Oh wait, that's not right," or it's like, "Okay, I'm seeing that it's failing." It's like, "Well, did you try this?" So, therefore, I don't have as good an internalization of the logic. By writing tests, I then validate that all the time. So even when I've got the logic wrong, I wrote a test to validate it wrong, and then when I then when I implement some more logic, I realized the other one was wrong. So the tests really help my understanding. At the same time, they give me confidence that like what's there is right. So I can go. I feel I can go a little bit faster, and not be worried about did I get everything right? If I want to change something, did I undo something, or just an assumption that I made a little while ago? Is that different? Does that make sense? Okay. Okay, so you're saying they should never reach here. Okay,
Correct.
so I want to poke around at some more dead guys.
Okay.
So then what should happen? Any dead with what happened? So if you're all dead, what should happen if you're all dead? What's the next state after
If you're all dead, they're all going to stay dead. They're going to remain
So
dead.
I don't think my code. My code does that.
Actually, it does. You've got the one that says that if you have a neighbor of 3 or more living, or of 3 living or more on a dead cell, it becomes alive. You've got if it has alive and 3 or more.
But there's no. If I have something that there's no alive. And so then the next cell generation should be dead.
Yep.
That's what you're saying.
Correct.
That should be true for all of them.
For all 9 of them.
Okay, well, I'll start out with this one. I don't know if my logic's implemented that way. I think we're gonna get the exception. Yeah.
Because you should never hit that unsupported op at this point.
But yeah, okay, so what's wrong with my logic then? Because like,
Generation Java.
no, I mean here's the method that does it, and I only the rules. Let me go back to the rules. You start with 2 and calculate the next generation. Follow these rules. Any live cell with fewer
Then 2 live neighbors.
any live cell. So I've got dead cells. The only one that talks about dead cell is this. So I think there's got to be more rules that talk about if you've got a dead cell with no live neighbors. Which rule covers that scenario?
Okay, rule 4. Any dead cell with exactly 3 live neighbors. So if it has less than 3, or if it has more than 3, nothing. It remains dead.
Okay, so basically,
So we need
exactly 3.
Yeah, so we need to come up with a logic that says that if you are dead and you have 3 live neighbors, come to life. Otherwise, stay dead.
Okay, and that's why I don't have it. I don't have the otherwise stay dead.
Yes.
So is it always dead? So if it's alive. So if it's alive and surrounded by
3 or more than 3, drops dead.
right, and that would be this one. It's less than okay. So then, otherwise it's dead.
We got. Okay. Perfect.
I think so. I think it's okay. Okay. I want to throw some more tests at it. Well, actually, wait a second. First of all, then I want to change for int row equals 0 while row is less than generation get number of rows row plus.
I can't believe you didn't get another A. I mean, we could see if they're.
For int column equals 0 while. Does that matter? It doesn't matter. While column less than generation get number of columns column plus plus. And then this is row, column. Okay, so this is like anything that is dead stays dead. Okay, that makes sense. Okay, let's run all of them now. That should be generation. Okay, all of them. Okay.
Because now all of our logic passes.
Okay, so okay, I want to start. Okay, now it's time to implement like the whole transition. Okay, make sure that dead cells. Well, dead. Dead.
Cell.
Yeah, generate. Oh, so the whole thing stays dead.
Perfect.
No resurrection.
No zombies.
Zombies. Yeah. Okay. Now we want to transition. So I think it's sort of time for the big test, right? I mean, like if we take this one. So.
That's 4 by 8.
Okay. Well, I think my code will figure it out.
Well, let's hope so.
Test. Okay. So public
static void. Or not static.
And we're going to call this example from code kata page. No, what page? Okay. So here we want this thing, and then we want string.
What's the most? The most
String. Okay, so let's see here. We want to test. So we basically want to say, oops. So that's the original generation. So generation next generation equals generation dot get next generation.
We need to create a new.
Yep. And then new unsupported operation exception. And then Excuse me. Well, okay, actually, let's do.
Oh, we're not checking that.
Let's create another. Let's do another one of these guys. Let's say they're equal.
So how would we check that?
And so, like, what was the next evolution? That thing goes to this.
Yeah.
Okay, and then we can say assert that. Oops. This thing. Oops. No. This thing. Generation equal to next generation, and we need to implement equals method. But let's get this. Let's run it first.
We're gonna break.
Okay, yep, unsupported operation exception. Okay, so now we need to implement this get next generation. So, oh, you know what? We don't have the generation number.
True, we don't have an
No, let's
initiation
not
point.
do that. Let's not do that yet.
Okay.
Like, I mean, like, so we're supposed to have, like, you know, generation 1, generation 2. Yeah, we can do that later. Okay, so let's see here. So first we'll create a new generation. Next generation. Generation equals new generation. This takes rows, columns. This dot rows. This dot columns. And then we'll say for int row equals 0, while row is less than this dot rows. Oops. Row plus plus. For int column equals 0, while column is less than this dot column. Column plus plus. Then we'll say next generation. Well, wait. It'll be cell state. Next state equals this dot get cell state for next generation. Row column. And then so next generation set cell state. Row column. Next state. Return next generation.
Perfect.
How does that look? Okay, we'll run it.
Should be spitting out the next cell then.
I think it would fail. Yeah, it
Yep.
looks like it's failing. Okay, so because we didn't implement equals.
Good point.
So public boolean equals object O generation other equals generation row. And then let's see here. We want to say we want to select for okay. Well, first of all, if this dot rows is not equal to other dot rows, return false. So obviously they're not the same if they have different numbers of rows. Else if this dot columns is not equal to other dot columns,
Return false.
return false. Otherwise, okay, they should be the same. Oops. For int row equals 0. Boy, I wish we had a better way of doing this. While row.
This is wordy.
Yeah, well, I think it's better than I and J, though, right? I mean,
True.
maybe for a Fortran programmer, but I think, you know, I guess I'd rather invest the time now. Column equals 0, while less than column is column plus plus. If this dot cell states row column not equal to other dot cell states row column, then they're definitely not false. If we get here, let's say return true.
Sounds good.
Let's complain about. Oops. Override annotation. What is it complain about? Equals should check the class as parameter. Ugh. Can it fix it for me? I really don't feel like. That's lame. Okay. if not O instance of generation turn false. There. Are you happy now, IntelliJ? Thank you. You made my code better. Okay. Okay. I'm surprised this passes. Oh. Okay. Well, that's good.
Because it checks the class, then it checks the status.
Yep. And so then, okay, so this guy. I want to see the pretty pictures like everybody else did. But we don't have a way of formatting it. It's almost 9 o'clock. Maybe I'll finish it up later. Awesome. Okay.
Say the normal cellular automata is either 12 by 12 up to 64 by 64.
Okay.
So good luck.
Yeah.
At least your logic's there.
Well, and it's I mean, I feel pretty good about it. You know, just even getting this much, I think it's pretty solid. And the code, well, I think it's pretty good. I think it's good enough for tonight. Awesome. Well, thank you.
Not a problem.
I really appreciate you coding with me tonight. I think you had a lot of good insight into the problem. It helped me go faster because you could like catch all the silly little things that I didn't. Okay.
Conway's
Very
Game
good.
of Life is actually a rather silly format because Conway had this idea that every single complex problem in life could be represented through a cellular automata. And then, of course, Gosper came up and said, no, what if we put this input in there? Then we're going to have an infinite regenerating loop.
Learning.
And then Conway said, well, that's just a possibility of life. It's like, no. Because to date, there are over 2,000 known gliders in the Game of Life.
Wow. That's what's so beautiful about it, right? It creates these pretty pictures and everything.
Nice repeating pictures that look great on GIFs.
Yes. Okay,
But,
so now I want to push.
It was funny because Conway had this assertion that somehow his cellular
Wow.
automata theory was the perfect method
2, 3, 4, 5, 6,
of representing complex information.
Interesting. That was 12 commits that we made. Okay, off to GitHub, and I think that's all for tonight.